Good morning, my YouTube viewers. It's Crystal here. I'm here this morning to do a code review about the top K accuracy score. But before I do the code review, I just wanted to go over what it is in the sklearn library. So the top K accuracy score function is a generalization of accuracy score. The difference is that a prediction is considered correct as long as the label is associated with one of the K highest predicted scores. Accuracy score is the special case of K equals 1. The function covers the binary and multi-class classification cases, but not the multi-label case. If Fij is the predicted class for the ith sample corresponding to the jth largest predicted score, and the ith1 is the corresponding true value, then the fraction of the current predictions over n samples is defined as. So they give you the formula for your top K score, and where K is the number of guesses allowed and 1x is the indicator function. And then they give you a sample code for the top K accuracy score. So I only heard about the top K accuracy score around yesterday. And since I heard of it around yesterday, I thought, oh, well, I want to go ahead and write a program using the top K accuracy score and also do a code review. So now that we've covered what the top K accuracy score is, we're going to go over a code that I've made. This is a glass identification data set using top K accuracy score. So the first thing that we're going to do is we're going to import the libraries. So we're going to import pandas SPD, which creates the data frames and processes the data. We're going to import numpy SNP, which creates numpy arrays and computes numerical data. We're going to import matplotlib.pyplot SPLT, which visualizes the data, and we're going to import Seaborn as SNS, which statistically visualizes the data. Then we're going to read the file into the program, and I got the file from GitHub, and it is a glass identification data set. So data equals pd.readcsv, and then the GitHub file. And so you can see glass, and you can see the type of glass it is. It only has 6 classes, not 7, because I believe that 4 is missing. So that can make things a little bit complex. So we check for null values. We don't have any null values, so that's good. So that means that we don't have anything to impute. And then we check to find out what kind of data set it is. And it's a numeric data set. So the ID number is integer, the type of glass is integer, and everything else is a float. So we describe it. So because every column is numeric, every column gets a description. We're going to drop the ID. We don't need the ID. The reason why we don't need the ID is because every row in pandas is already indexed. Now we're going to use Seaborn to visualize the target by making a histogram. So target equals data.pop, type of class, sns.dispplot, target KDE equals true. So we're missing a 4. You've got 1, 2, 3, 5, 6, 7. So we're missing 4. So that means we have only 6 types of glass. We do num class equals target.value counts, and then so you can see all of the counts of each value. Number 2 is the highest, and number 6 is the least. And you can see that. We check the unique values, the number of unique values, and the target, and there's only 6 unique values. And now what we're going to do, and we have to process the labels. And the reason why we have to process the labels is because number 4 is missing. And because number 4 is missing, we have to process the labels. And then, so from sklearn import preprocessing, LE equals preprocessing dot label encoder, target equals LE dot fit transform target, and then there's your target. Now we use Seaborn to create a heat map, and you can see that the columns don't necessarily look highly correlated, but I just wanted to be sure. So this is the correlation of the columns. And then so I wanted to see if any of the columns were correlated higher than 95%. And there's nothing correlated higher than 95%. So that was good. Now what we're going to do is we're going to standardize the data. So data equals data minus data.mean over np.std data. And this is your standardized data. We're going to define our x and our y. Your y is your target, your x is your data. And then I wanted to see the unique values of y, so we printed the unique values of y. It's 0, 1, 2, 3, 4, 5. So that means there's 6 unique values. And we also are going to one hot encode y. So y hot equals pd.getDummiesY, and y hot 0, 1, 2, 3, 4, 5. So you can see that the label has been one hot encoded. Now what we're going to do is we're going to split the data, and we're going to split it in 2 ways. So the first thing we're going to do is we're just going to split the data in x and y, size equals 0.2, random state equals 42, shuffle equals true, and then you print x train shape, x val shape, y train shape, y val shape. So you can see the shapes of the data set because that's what you want to see. And then we print the values, the unique values of y val, and you can see it's 6 unique values, which is what you want to see. Now what we're going to do is we're going to split the data set into the one hot encoded. So x train, x val, x train hot, x val, y train hot, y val hot equals train test split, x, y hot, test size equals 0.2, random state equals 42, shuffle equals true, and then we check the shapes is x train dot shape, x val dot shape, y train hot dot shape, y val hot dot shape. So you can see that the x variables have 9 columns, whereas the y variables have 6 columns because they've been one hot encoded. Another thing that we want to do is we want to define our class weights. So from sklearn.utils import class weight, weights equals class weight dot compute class weight equals balanced, classes equals np dot unique y equals y reshape -1, weights equals dict zip np unique y weights, and these are your weights. So you've got 6 weights. So now what we're going to do is we're going to do deep learning. And in order to do deep learning, we need TensorFlow. So we're going to import the TensorFlow library and its sorted modules. And now what we do is we create a sequential deep learning model, and this is the sequential deep learning model that we have created. And you can see the input is the shape of X-train columns. And then we've got like two dense layers of 25 neurons each. Activation equals reflow. Name equals layer 1 and layer 2. We've got a dropout layer to hopefully improve the accuracy. And then the final layer is a Y-train hot dot shape 1. So that's going to be 6. Activation equals softmax. Name equals outcome. So you can see that we've got a summary of the model. So now what we do is we compile the model. The loss function is categorical cross entropy. Optimizer equals atom, and metrics equals accuracy. We set up our callbacks, and we set the callbacks up for a patience of 25. And then we train the model. We set up epochs of 400. So then we train the model. History equals model.fit, X-train, Y-train hot, epochs equals epochs, validation data equals xval, yval hot, verbose equals 1, callbacks equals my callbacks, class weights equals weights. So we've set it up for early stopping, so it stops at 299, and it gives you an accuracy of 79. Then what we do is we use matplotlib to create a plot of the loss and the accuracy. And so you can see that the accuracy has stabilized around 75, around that area somewhere. And the loss is continuing to decrease. We evaluate the model, and we had a 79% accuracy when we evaluated the model. And then now what we're going to do is we're going to YPRED prob, and I'll go ahead and take that out. YPRED prob equals model.predict xval, and here's your YPRED prob. So each YPRED prob has got six values in it. And then YPRED equals NP argmax model.predict xval, axis equals -1, and that's for a multi-class, which is what we have. YPRED equals YPRED flatten, YPRED. So you can see we've got the 0 to 5, which gives you 6 outputs. Now we're going to check the top K accuracy score from sklearn.metrics, import top K accuracy score. Calculate the top K accuracy score. Top K accuracy equals top K accuracy score, yval, YPRED prob. And then we print it, and we had a 95% on the top K accuracy score, because that gives you, if it's in the top 2, it counts it as a positive. Now we check the accuracy score from sklearn.metrics, import accuracy score. Accuracy score equals accuracy score, yval, YPRED, and then we print the accuracy, and that's a 79%. So with accuracy, it's a top K of 1, whereas the top K here, the previous top K, the default was 2. So we could have, in theory, set the default up to 3, and that might even make your accuracy better. So we go to create a data frame of actual and predicted values, so you can see that. And then YPRED, we inverse transform YPRED, so you can see what the actual values are when we inverse transform them. And then now we create a histogram of the predictions, which is YPRED. But what I'm interested in is, because accuracy score is the K equals 1, and then the top K is k equals 3. So if we come over here and we come over here to top k accuracy score, and we say k equals 3, let's just see what happens when we say k equals 3. Okay, let's see what happens when we say k equals 3. So when k equals 3, it's 100%. So I guess that's one way you can improve your accuracy is use top K accuracy score, and that will improve your accuracy if you do that. And I got the top K accuracy score from a research paper, so I intend to do a research paper review and to use the top K accuracy score, but I wanted to learn how to use the top K accuracy score first, so it's very interesting. So the one thing that we've picked up from this code review is accuracy score K equals 1, top K accuracy score. The default is k equals 3. No, sorry. The default is k equals 2, but you can set it up for any k value that you want. So I'm going to go ahead and conclude this code review because we have talked about all the things that we want to talk about on this top K accuracy score. I'm going to do a blog post on this code, and I'm also going to do a research paper review and use this as part of the research paper review as well. So thank you so much for watching my video. Thank you to my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you again for watching my code review. I look forward to making more code reviews for you in the future.